This is pre-algebra lesson 4-9, scientific notation. Scientific notation is a number written as the product, which means the multiplication, of a number greater than or equal to 1, but less than 10, and a power of 10. For example, scientific notation for a number could look like this: 2.6 times 10 to the 5th power. 2.6 is a number that is greater than 1 but less than 10, and it is multiplied by a power of 10, which means that it follows the definition. It's a number written as the product of a number greater than or equal to 1 but less than 10, and a power of 10. Now you can change numbers from scientific notation to standard form, and from standard form to scientific notation by simplifying the product of the two factors. And strangely enough, remember how I told you I do not like you using the x for multiplication? Scientific notation uses the symbol x to avoid the confusion with the decimal point in the first factor. Therefore, you'll rarely see scientific notation written with a decimal point like that for the multiplication part. And you will see it written with the multiplication symbol that you were used to seeing when you were younger. Okay, now, the exponent with the 10 shows the number of places you're going to move your decimal point. A positive exponent indicates that the number is greater than or equal to 1, and a negative exponent indicates the number is less than 1. Okay, we're going to talk about how we deal with scientific notation. Okay. If I wanted to write a number in scientific notation, it's actually very simple to convert between one form and the other form, as long as you understand how to do it. Okay, so I have 6,300,000. As you can clearly see, some people can read that number very quickly. Others would have a hard time reading it. That's why scientific notation is so handy. Also, many calculators can't hold that many digits, so a calculator sometimes naturally translates a number into scientific notation to make it easier to display. So if we have 6,300,000, in this number, 6,300,000, normally the decimal point is at the end of the number, so the decimal point would be here at the end of this 0. We need to move the decimal point so that there is only one digit in front of the decimal point, and that digit is not a 0. Okay, because this is a positive number. It's the whole number, and it's larger than 1. So we actually need to move the decimal point from here all the way between the 6 and the 3. So this would become 6.3. We're going to leave off all the extra zeros because we do not need them anymore. How many places did we move that decimal point? Well, we started here at the end of the 0. We moved it 1, 2, 3, 4, 5, 6 places. So that means it's going to be multiplied by a power of 10 that is positive because it's a big number. And we moved it 6 places, so it's 6.3 times 10 to the 6th power. Okay, you move the decimal point 6 places. The number is large, so 6 is the exponent of the 10, and it's not a negative 6, it's a positive 6 because it's a very big number. We took a big number and made it smaller, which means our exponent should be a positive number. Now we're going to take this next number, which some people have a very difficult time reading. It's 3,700 thousandths. Okay, and 3,700 thousandths, we already have a decimal point. We need to move the decimal point so that there is only one digit in front of it that is not a 0. It's got to be a number greater than or equal to 1. So we need to move this decimal point from here to the middle of between the 3 and the 7. So our decimal becomes 3.7. Okay, and we're going to multiply it by a power of 10. We moved it, if you notice, we moved it 1, 2, 3, 4 places to the right. We moved it 4 places. We took a small number and made it bigger. Since the number was small to begin with, that means the exponent on the power of 10 needs to be small. So in other words, it needs to be negative. So we need to make it a negative 4. Okay. The number is small, so we have a negative power of 10. So 3.7 times 10 to the negative 4th power. 54,500,000. Okay, again, we need to put our decimal point so that there's only one digit in front of the decimal point that is not a 0. So it needs to go between the first 5 and needs to go between the first 5 and the 4. So I move our decimal point so it should be 5.45. We can leave off the zeros. You can't leave off digits that are not 0. So we have to leave the second 5 in there, but we can leave off all the other zeros. We started with our number at the end of the number, at the end of the 0. We moved it 1, 2, 3, 4, 5, 6, 7 places. And it's a big number that we made smaller. We took 54,500,000 and made it 5.45, so it was big. We made it smaller, so it has to be a positive power of 10. All right, and if you remember, we said that was 7 places, so it's the power of 10 is 7. 5.45 times 10 to the 7th power. Okay. Ooh, look, some more small numbers. 0.00021 or 21 times 100 thousandths. Okay, so 2100 thousandths. So the decimal is going to go between the 2 and the 1. And we moved it 1, 2, 3, 4 places. And since we made this number smaller, when we made this number bigger, it was small. We need to make sure we indicate that it was small, so it's a negative power of 10. You put 1 times 10 to the negative 4. And last but not least, a number I can't even read because it's so far out there, I'm not even going to try to read it. Okay? Very large number. My decimal point goes between my 8 and my 0. And it's going to be 9 times the power of 10. I know it's going to be a negative power of 10 because this is a teeny tiny number. Small number. Okay? This is a much bigger number. 8.03 is much larger. So I have moved the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. So it's the negative 12th power, which is much easier to read. It's much easier to read 8.0 times 10 to the negative 12 than it is to read, let's see here, 12. Negative 12 will be trillions. It's 803 trillions, I believe. There's tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 millions, 100 millions, trillions. Yep, it's 803 trillions. Okay. Large number. See, it takes me so long to read that because you have to think about it so much. All right, now, so we just transferred numbers from standard form to scientific notation. Standard form is the way you're used to seeing a number. Scientific notation is a number times the power of 10. So now if we have a number that's written in scientific notation, we need to be able to transfer it to standard form. Okay? This is quite simple. To transfer a number from scientific notation to standard form, you're just going to move the decimal point the same number of places as the exponent is. So on 3.6 times 10 to the 4th, we're going to move the decimal point 4 places. The 4 is positive. On a number line and a horizontal number line, positive goes to the right. So we'll move our decimal point to the right. So we start with 3.6, and if we move our decimal point to the right 4 places, 1, 2, 3, 4, I put the zeros in the little dips, it becomes 36,000. So my answer is 36,000. Number 2, 7.2 times 10 to the negative 3rd. Here, the exponent is negative, so we're going to the left, because going to the left is negative on the horizontal number line. So I'm going to move the decimal point 3 places to the left. 1, 2, 3. Put my decimal point, and then the little dips will be the zeros. So it's 0.0073 is our final answer for this. 73 thousandths. Number 3, 3.21 times 10 to the 7th. So 3.21, I'm going to move that decimal point 7 places to the right because it's a positive exponent. 1, 2, 3, 4, 5, 6, 7. How many zeros do I add? 1, 2, 3, 4, 5, 6. I messed up 1, 2, 3, 4, 5, 6. Yeah, I have 2. I already had 2 places I needed to move it, and I needed to move it 5 places more to make 7, so I had to have 5 zeros. So 3, 2, 1, 2, 3, 4, 5. 32,100,000. Excuse me. Number 4, 5.9 times 10 to the 8th. Excuse me, 5.9 times 10 to the negative 8th. Big difference. So I have my 5.9. I need to move my decimal point left 8 places. 1 place gets it in front of the 5, which means I need 7 more zeros in front of that. So 1, 2, 3, 4, 5, 6, 7, 5, 9. And you can put a 0 in front of the decimal point. A lot of people do, or you don't have to. It does not change the number if you do or don't have that 0 in front of the decimal point. Now, to preserve the value of a product, if you increase the value of one factor, you must decrease the value of the other factor. Okay? For example, if I have 0.37 times 10 to the 10th, that's not written in scientific notation. If 0.37 doesn't have one digit, it doesn't have a number that's greater than or equal to 1 but less than 10. This is less than 1. So if I increase the value of 0.37 to 3.7, then I must decrease the value of 10 to the 10th to 10 to the 9th. Okay? An easy way to look at that is I look at it this way. I tell people you've got 0.37. If I was to times 10 to the 10th power, okay? If I was to just work with this number, just the 0.37, if I change that to scientific notation, that would be 3.7 times 10 to the first, wouldn't it? And I still have a times 10 to the negative first, because I made it bigger. Okay? I still have my 10 to the 10th there. So 0.37 becomes 3.7 times 10 to the negative first, and I still have a times 10 to the 10th here. And remember, we've learned earlier that if we have numbers taken to the same base, we can add their exponent. Negative 1 plus 10 is negative 9, so that's how you get 3.7 times 10 to the 9th. Okay? This 0.37 got bigger, so this has to get smaller. Okay, so let's write the following numbers in scientific notation. 16 times 10 to the 5th. Okay? Well, 16 would be written as 1.6. Okay? This one got smaller. Okay? This number got smaller, so basically 16 becomes 1.6 times 10 to the first power. And we already have a times 10 to the 5th power. We add the 1 and the 6 together, we get 1.6 times 10 to the 6th power. Okay? Because we didn't increase the value of the 16. This went down, this went lower. So this has to go higher. If you change one direction, you have to change the other one another direction. All right, 0.203 times 10 to the 6th. 0.203, if we wrote it in scientific notation, would be 2.03 times 10 to the negative first times 10 to the 6th. So I have 2.03 times 10 to the negative 1 plus 6 is negative 5. This number got bigger, so this number has to get smaller. Shouldn't be negative 5, should be positive 5. That was my mistake. Negative 1 plus 6 is positive 5, not negative 5. So as the 0.203 got larger to 2.03, 10 to the 6 got smaller to 10 to the 5th. 7,243 times 10 to the 12th. Okay, so here we go. 7,243. Go to the scientific notation, 7.243 times 10 to the third power. And I already have a 10 to the 12th power, so if I add those together, I'm going to get 7.243 times 10 to the 15th power. Now notice this number got larger, or it got smaller by 3, okay, 1,000 basically, because basically we divided it by 1,000, or 10 to the third. This has to get bigger by 3 places to 10 to the 15th. It's a whole lot easier if you do the scientific notation thing like I showed right here. Change it to scientific notation and then add your bases together and you'll be just fine. But we already know how to do that from earlier in this chapter. Last but not least, you can multiply numbers in scientific notation using the rule for multiplying powers with the same base. I basically was doing that just a minute ago. If I multiply, I'm going to express my result in scientific notation. If I have 7.1 times 10 to the negative 8, and I'm going to multiply that by 8 times 10 to the 4th. Okay. Equate the number part. Okay. That would be the 7.1 and the 8. So I'm going to multiply 7.1 times 8. And we're going to do equate the power of 10 part times 10 to the 8 times 10 to the negative 8, 10 to the 4th. Okay. So 7.1 times 8 is 56.8. This is going to be 10 to the negative 8 plus 4. So we now have 56.8 times 10 to the negative 4. But we're not done at this point in time because it says express your result in scientific notation. And this isn't quite in scientific notation yet. It's close. It's partially in scientific notation. We need to change the 5.68 to become, let's see, 56.8 to become 5.68 times 10 to the first, because we got bigger number what's smaller, so it's positive power of 10, times 10 to the negative 4, which makes this 5.68 times 10 to the negative third. And we're done because now it's in scientific notation. So you multiply the regular numbers. If you add the exponents to the powers of 10, if it's not in scientific notation, you convert the whole thing back to scientific notation. Let's do one more. 2.3 times 10 to the 6th times 5 times 10 to the third. So 2.3 is multiplied by 5, and 10 to the 6 plus 3. Okay, 2.3 times 5 is 11.5 times 10 to the 9th. But 11.5 is not written in scientific notation. So we have to change this to be 1.15 times 10 to the first times my 10 to the 9th that I already have. So this becomes 1.15 times 10 to the 1 plus 9, or 10 to the 9th power. Okay. Scientific notation. Very simple to do. Very helpful because it's a whole lot easier to read 8.2 times 10 to the 15th than is try to figure out if that's trillions or quadrillions or quintillions or something strange like that, because most people don't really know numbers much larger than trillion. So this is scientific notation.